You know, another thing that Einstein's theory of relativity predicted was black holes. And let me show you how you can explain what black holes are all about using this equipment over here. This is a 4-pound ball, which I will put in my fabric of space-time. And you can see that it curves it a certain amount over there. A heavier ball would curve it more, a ball that's not so much would curve it less. But the point is that 4 pounds of ball curves the space like that. It doesn't matter how I get 4 pounds over there. Out here, it will still curve it the same amount. So if I were to take a different ball and crush it down, let's say I make it out of lead, it still was 4 pounds, it would be a lot smaller over here, but out here, it would be exactly the same. Or if I took that other ball, ball and like really squeezed it down so it was really dense, like plutonium or something like that, it might only be this big and 4 pounds. It would pull down that cloth differently down over there, but out here, 4 pounds of pull is 4 pounds of pull. Well, supposing that I were to keep on compressing that 4 pounds, smaller and smaller and smaller, it's like a BB. Now it's like a pinpoint. Eventually, I would get a situation where you still have that curvature, but the ball is so small that you can't even see it anymore. And that's really what the idea of a black hole is that the space-time is curved, but the mass that's curving it is so small that you can't even see it. Another way to think about it is this. Watch, if the planet rolls around up here, it goes a certain speed. If the planet rolls around down there, it's going faster. As a matter of fact, it goes faster and faster and faster and faster as you get closer and closer and closer to it. If you were to have a star, you can only get so close to the 4 pounds because the star is in the way, and so it'll only go so fast. But if you don't have that star there, it'll go faster and faster, and if it goes faster than the speed of light, that's when it drops through that hole. That's when you can never get it out, and that's really what a black hole is. So the way that Einstein's theory of relativity predicted black holes is because of this curved space-time where the mass doing the curve is so small and so tiny that things move faster than the speed of light as they get closer to it. That's another thing you can show with this piece of equipment.